If you remember in Unit 9, we talked about greatest common factors. Well, in Unit 10, Part 2, we're talking about least common multiples, which are basically the opposite of greatest common factors. So, a couple of definitions for you when we're talking about finding the least common multiple. A multiple is the product of a number at any non-zero whole. So, for instance, a multiple of 6 would be 12, or 18, or 24. Okay, so the number times a non-zero number. A common multiple is just a multiple that's shared by 2 or more numbers. So, for instance, 12 is a multiple of 4 and 6, so that's a common multiple. And then a least common multiple, just like the greatest common factor definition, it basically just explains what it already says, is that it's the smallest of these. So, we're going to look at how to find the least common multiple of numbers. So let's start with the first. And let's start with the pretty basic one. We have 4 and 14. We're going to start by doing factor trees. So for 4, that's 2 and 2. I can go ahead and circle those. For 14, that's 2 and 7 are the only multiples. So I'm going to go ahead and circle that. So the next thing I need to do is write all these factors out. So for 4, I have 2 times 2. For 14, I have 2 times 7. So up to this point, it's exactly the same as greatest common factors. Now we need to do something. Now the next step is what's going to be a little bit different. So we want to start by circling what they have in common. So they have a 2 in common. Now to find the least common multiple, we're going to multiply all of their factors, but if they have it in common, we only count it as one number. So here's what I mean by that. So to find the least common multiple, I'm going to do 2, which comes from the 2 circled ones, times 2, which is the one that's not circled, times 7. So my point is, the 2 that they have in common, I only count that once. So then when I multiply that, 2 times 2 is 4, times 7 is 28. So the least common multiple of 4 and 14 is 28. Number 2, I'll let you do. I'm going to go over how to do number 4, and then you can go back and do number 3. So I'm going to be looking at number 4. I'm going to start the same way. I need to do a factor tree for every number. So for 14, my factors are 2 and 7. Go ahead and circle those because they're both prime. For 21, I'll have 3 and 7. I can circle those. Those are both prime. And for 35, I'm going to have 5 and 7. I can circle those because they're both prime. The next thing I need to do is list out all my factors. So for 14, I have 2 times 7. For 21, I have 3 times 7. For 35, I have 5 times 7. Now, I'm going to circle what they have in common. And so, in this case, they all have this 7 in common. So when I go to multiply now to find my least common multiple, I'm going to do 2, which comes from right here, times 3, which comes from right here, times 5, which comes from right here, and then times 7. And there's 3 7s, but they all share that, so I only count it once. Then when I multiply all that together, 2 times 3 times 5 times 7 gives me 210. So that's going to be my least common multiple. Now, I didn't take a good example, but if you remember from greatest common factor, when we do more than 2 numbers, like we do 3 or 4, whatever numbers, they all have to have the number in common. For least common multiple, you only need 2 of them to have in common in order to circle. So for instance, if I didn't have this 7 here, I would still circle those in just 2 of them. We'll talk about it more when we get to examples. Moving on to the next section, we're going to find the least common multiple of monomials. Remember, monomials can have numbers, variables, exponents, all that, but it's all together as one product. Okay, there's no addition or subtraction between them. So, number 1, I'm going to hold off and let you guys do that in a second. I'm going to do number 2 for you. We're going to start the same way. Okay, we want to do factor trees. Now for 3, that's really easy because the only factor it has is 3. For 20, I want to break that into 4 and 5. And then 4 I need to split into 2 and 2. So now, when I'm finding the least common multiple, I can go ahead and write these out. So for 3, I have 1 times 3. I don't really even need to write the 1. For 20, I have 2 times 2 times 5. Now, for the variable part for this, I'm going to leave it and show you a shortcut for that. So, I can go ahead and see if I have anything in common. If you look, 3 and 20 don't have any factors in common. So when I'm finding my least common multiple, that means I'm going to multiply all these factors together. I can ignore the 1, so I have 3 times 2 times 2 times 5. Again, 3 and 20 do not share any factors, so I'm going to write all those out. So when I multiply all those together, I'm going to get 60, and then I still need to worry about the variable part. If you look, I have g to the 5th and g to the 2nd. When we're doing least common multiple, we're always going to take the higher exponent. So it'll be g to the 5th. So that'll be my least common multiple there. Right. I'll let you guys go ahead and do number 1. Flipping over to the back side. I'm going to leave number 4 for you guys. I'm going to go over number 3 because it's a little bit trickier. Again, I'm going to start with factor trees. So for 21, that's just a 3 and 7. Those are both prime I can circle. For 84, I can split that into 21 and 4. 21 I'll split into 7 and 3. 4 I'll split into 2 and 2. And I'll leave the variables for the end. So for 21, I'm going to write out my factors. That's 3 times 7. For 84, that's going to be 2 times 2 times 3 times 10. The next step is I want to circle what they have in common. So they have 3 in common. They have 7 in common. So when I go to multiply for the least common multiple, I have the 2 from right here. I have the 2 from right here. I have the 3 that they have in common. And I have the 7 they have in common. Again, recognize that I only write 3 once, and I only write 7 once. When I multiply all those together, 2 times 2 times 3 times 7, I'm going to get 84. And then we need to look at the variable parts. I have m squared and I have m, so I take the higher one, I'll take m squared. And then I have n and n to the third, I'll take the higher one, sorry, n to the third. That's what would be an n. So my least common multiple is 84 m squared n to the third. Number 4 I will leave for you guys. All right, the next thing we're going to talk about is least common denominator. The least common denominator is just the least common multiple of the denominators of 2 or more fractions. So we're doing the same concept, least common multiple, we're just applying it to fractions now. So it says use the LCD to determine which fraction is greater. So what we need to do is find the least common denominator and then write the fractions with that least common denominator. So 1 I'll leave for you guys. I'm going to show you number 2 because it's a little bit harder. So again, we're going to start with factor trees. So that's 4 and 5. I can circle the 5. And I'll break down the 4 into 2 and 2. For 46, I'll split that into 23 and 2. Those are both prime, so I can circle those. I need to write out my factors now. So for 20, that's 2 times 2 times 5. 46, that's 2 times 23. The next step is I want to circle what they have in common. So they have a 2 in common. So then when I go to multiply to find my least common denominator, I'm going to have the 2 that they have in common times this 2 right here, times the 5, times 23. So my least common denominator for 20 and 46 would be a huge number of 460. Now, the directions were to determine which fraction is greater, which I have not done yet. I found the least common denominator. I haven't figured out which one's greater. In order to figure out which one's greater, I need to rewrite both of these with 460 as their denominator. So for 9 over 20, I need to decide 20 times what gives me 460. So I know that 20 times 23 gives me 460. So I'll also do 9 times 20, which will give me 207. Then I need to say 46 times what gives me 460, which is just 10. So I have to do 19 times 10, which gives me 190. So that I know from comparing these that 9 over 20 is the greater fraction. I'll leave number 1 for you guys, which is a little bit easier version. This word problem, I want you to just do your best to try it out, and then you know the review problems you do on your own. Review of prime factorization. Make sure you check the review problems with the answer.